Okay, class, Assalamualaikum and very good evening. Welcome back to the class. Okay, let me share the screen. Okay, class, this is, can you see my screen now?
Yes.
Okay, good. Okay, so this is the, this is problem 2.2. Okay, let us do the problem 2.2. So let me, this is the video. Okay, I just got the video and I uploaded the first video. Okay, you can see later. Okay. So as exercise 2 we will use, okay, exercise okay, this is exercise number 2. Let us start now. Bismillahirrahmanirrahim. Based on the problem 2.2. Okay, the first thing that I want you to know is what is the difference between problem 2.2 and problem 2.1? Anybody? Anybody can tell me?
Dah bagi 3H20.
Sorry?
Dah bagi 3H20.
Bagi 320. Okay, TH20. Okay, means macam ni. Yes, good. Problem in problem 2.1. Okay, the bending moment is given. The design moment. Design moment is this is the demand. Okay, this is the demand. So the demand is, let's say, 200 kilonewton meter, and then the question asks you to find the AS, which is the supply. Okay, which is the supply. Okay, demand will create AS required, and AS required will create the AS, which is the supply. So about the problem 2.2 is this one is already given. Okay, this one is already given. However, it asks the ultimate moment of resistance, which is what is the supply or the capacity of the bending moment provided. So the bending moment cannot over the provided. So can we do it now? Okay, why not? We just use the similar data. So 250 mm, and then the D is 500 mm, and then this is let's say 550 mm, and then why not we use 5H16, and then the concrete class is C30/37. Okay, I give you 1 minute to write down these informations. Okay, let's say this one is 5H16. So we want to know the capacity. Okay, for this week we only cover the rectangular shape of the beam. Okay, I give you 1 minute to write down inside your paper this one. Okay, sorry. Okay, you write down 1 minute. Okay, class. Have you finished? Okay, if yes, so we can do the answer now. The answer is very simple. Okay, this is means we want to find the we find the capacity. Okay, find the capacity means the moment resistance. Okay, or we call as the the moment of resistance. Okay, the moment of resistance. The what we did in problem 2.1 before is you are given the moment, the design moment. Design moment means the demand. Okay, moment of resistance means the supply. So what you're going to do is you must okay, if your okay, you have to remember that your beam is like this one. Okay, they say you have the reinforcement is 5H. They say okay, sorry, we change, can we change it to 4H20? Okay, 4H20 is better example. Okay, we change to 4H20. So this one is 4H20. Okay, for better example. Okay, so one row, so it's at the bottom. So so this beam is located at support or at midspan.
Midspan.
Okay, midspan, because the tension reinforcement is at the bottom. So okay, if the midspan, your beam, you will have three possibilities. First possibility is rectangular shape. Second possibility is L shape, and the third possibility is what? Anybody know the third possibility? The shape of your beam? T.
Dia bentuk macam T, doktor. Tapi
Okay,
saya
good.
betul.
T shape. Okay, T shape. If your beam is located at the midspan, but I like you to inform you. Okay, I will explain again in next tutorial. If your beam is located at support or the cantilever, okay, cantilever beam, cantilever or okay, what is the possibility of your shape? Anybody know? The shape of the beam. How many possibility?
2. Rectangular and L shape.
Rectangular and?
L shape.
Rectangular and L shape. Okay, good answer, but let me know. Okay, I want you to know that you only have one possibility, which is only rectangular. Okay, I will explain later why near the support or for the cantilever, the beam design only consider rectangular shape. I will explain later. Okay, so this one, so the compression is located here. Okay, this is compressions, and this one at the bottom part is here is in tension. Okay, so you must be okay. Recall back your shape of this one. Okay, the stress block. Okay, this is for compression is at the top. Okay, compression and tension is at the bottom. Compression is covered by the steel, right? Compression is covered by the steel. So it is FST. Okay, forces of the steel, forces inside the steel, and then this one is FS. Okay, FCC. Okay. Okay, FCC means the forces is okay, forces in concrete due to compression. Okay, to cater for compressions. Okay, not due to lah, for compressions. Okay, and then FCC FST is forces in steel bar for tension. Okay, you must remember this one first. Okay, this is FST. If you keep pressure, okay, recall back your physics in during your school time. Pressure is equal to forces divided by what? By area, right? So to got the F is pressure times the area. So the pressure is by the strength of the steel, or strength of the compressive strength, or tension strength of the compressive strength of concrete, or compressive strength either FCU, okay, okay, either the compression strength of concrete, or by the FYK, yield strength of steel. Okay, if FT, so this is you must use FYK. If FCC, you must use the FCK. Okay, so the area is either area of steel, area of steel bar, or area of tension compression zone. So this is the area of compression zone. This is compression zone here. That's why you have the B. This is the value of B. Okay. So you just and B, and then this is your X. Okay, you can watch my previous video on how to derive the equations. So you must just keep remember that in order for equilibrium, so the F forces in steel is equal to the forces inside the forces in the concrete must forces in concrete for compressions must equal to forces in steel for tensions. So then okay, how to get the 0.85 and so on. Okay, you can refer to my previous video. Okay, so just remember the B times X, okay, 0.45 is okay. You can refer to my previous video, or I will get back to you later. Okay, so we must here the basic is here. So we must find the forces in concrete first. So this is a P, pressure, and this is the A. A is area of steel bar. So we have, let's say I redraw again here. This is the stress block. Okay, and then we have the here is B. It's okay. You do it again, and then you do this is your X. Okay, and this is your at the center is your FCC, and here FST. So B times X is your what? B times X is your area, right? So here FCC is equal to FST equal to pressure is 0.45 okay times FCK as I mentioned before. Okay, this one, the P is 0.45 times FCK, okay, the compressive strength. Okay, this is equal to 1 over. Okay, so this is the pressure. Okay, this is the P. You just understand the concept. I will come back to you later how we get 0.45. Okay, you don't have to worry. So times times area. Area is B times X. B times X is the B times X is the area. So B times X. Okay. Equal to 0.87. Okay, 0.87 FYK, and then this times area of steel. Okay, 0.7. Okay, so can you relate to this concept? Okay, pressure is equal to force divided by area. So what we are going to do is we want to find the force, so we must multiply the pressure to the area. So okay, this one is your this is your P pressure, and this is your area for concrete, and this is your pressure. Okay, the strength, the yield strength. Okay, that's why the unit is Newton per millimeter square, kan unit dia. So this is the forces, unit of forces, and this is unit of area. Divide F equal F divided by A, and so this is the A. Okay, any questions up to now? So you get, for this to solve this problem, you get the value of X here. X is equal to what? You solve this very simple equation, 0.87 FYK times AS divided by 0.45 FCK times B. Okay, this is the X. Okay, and then so the simple calculate the bending moment here. This is the the Z. Okay, Z, and then D minus, okay, D. Okay, so the bending moment is this one. Okay, we want to find the moment around here. FST times the Z, so we can get the moment. Okay, moment capacity means, okay, here okay, moment is equal to FST times Z. Okay, Z is here. This is the Z. You can refer to the previous notes. Okay, FST is equal to this one. FST is equal to this one. Here is the value of FST. So 0.87 FYK times AS times the Z. Z is equal to D minus 0.4x. D minus 0.4x. It's okay. You can refer to previous notes on how to derive a D how to get Z is equal to D minus 0.4x. Okay. I will explain later. Okay. So what is the value now? Can somebody tell me? Can we solve the problem now? 0.87 FYK. What is the value of FYK? Class, you stay with me? What is the value of FYK?
500.
500. Okay, good. Okay, what is the value of AS now? AS for 5H. 4H. Sorry?
1257.
57.
Okay, good. 1257 times D. What is the value of D?
500.
500.
Okay, 500 minus 0.4x. Okay, so okay, sorry, for this case, we must find the value of x first, right? Okay, so find the value of x first. Sorry, yeah. Okay, x is equal to tadi 0.87 FYK times AS divided by 0.45 FCKB. Okay, so equal to 0.87 500 times dengan 1257 divided by 0.45 times FCK. What is the value of FCK? 30, right? 30 times 250. Okay, what is the value of X?
162.01.
Sorry?
162.01.
62.01. Okay, mm. Okay, so you substitute the value of x here. So what is the value now?
238 kilonewton meter.
Sorry, sekejap ya. Kita tarik balik lah. Saya suka. 0.87 500 times 1257 times dengan 500 minus 0.4 kali 162 kan? Okey, berapa tadi jawapan dia?
238 kilonewton meter.
238 kilonewton meter. So this is the capacity of the beam. Okay, it's okay. I will give you the exercise later. I will just change the value of B. I change the value of D. I change the value of concrete class and the value of this one, the combination of steel. I will change, and then you will practice. Okay, but you must know the concept. And in our last in our last final exam questions, the section is like this one, right? T shape, kan? T shapes and ada apa? Ada void, betul tak? Ada void, betul? This one is quite confusing on how to determine the area here. Okay, the area here is quite confusing because it should be simply if no void, the case is like this one. Okay, so simply B times X is equal to area of steel. So it's okay. I will give the exercise by tomorrow morning, inshallah. Okay, I must do it first so I can release the exercise to you. Okay. Thank you very much for your participation. Okay, I will stop recording now. Thank you.